This is going to be our third video on arrays, and we're going to talk about some more advanced concepts. In particular, we're going to talk about parallel arrays or arrays that are lined up to have more data about something. And we'll also talk about multi-dimensional arrays. We'll do two-dimensional arrays with rows and columns, but that really can be extended out. Okay. So for the first example, it's pretty straightforward. The idea of a parallel array. Okay. So if you have more than one array that's going to hold information about the same item, so they're related, okay, then you have parallel arrays. And it turns out most of the time that if you're going to have parallel arrays, there's probably a better way to do it, and the multi-dimensional arrays would certainly be one way to do it. But there are other things that we'll talk about. But it's still a good concept to know. And in simple cases, it could be useful. Okay. So we're going to take a look if we have a class. So there's students in a class, and we want to have an array of the student IDs, and we want to have a corresponding array of the course grades. So if you're at position 10 in the student ID, the value at position 10 in the student ID array will be the course grade for that student that's held in the course grade array also at position 10. Okay, so they're lined up. Okay. And the example that this is from the book that we'll talk about is going to assume that the data is in a file. And I know the lab had a file component, and a lot of us were a little bit rusty on files. So this would be a way to talk about some ways we can use files as well. Okay. Um, so let's talk about that. So in this case, I just have my normal include IOStream. I'm including FStream because I'm going to be using a file. Okay. And of course, I'm using namespace standard. So we're just going to declare these two arrays, and they should be the same size. Note that this is what the book has, but like that. So let's do a constant int size equal to 50. Do it this way. I think it's worth the effort, even if we're not doing much on this one. Okay. So this one, I think one of the things that I'd forgotten, I don't use files in C++ every day, is that our files should be space delimited for easy access. A lot of files you see are comma delimited with a comma in between, and using the standard file stream in C++, the commas are an extra step. Okay, so we're going to assume our data is going to be just an ID, space, letter grade, each on their own line. Okay. So once we've done that, once we have that file, which I don't really have, so I'm not really going to run this, but here's how we could load the data from that file into our array. Okay. And again, we're seeing one of the limitations of arrays here in that we have to set the size to be 50. So we have this file we're going to read in. We may know that we have 50 students. We may know exactly how many students we have. Okay. In which case, there's no waste. But if we don't know, then we have to make a guess. If we guess too big, so we say that think there are more students than there really are, then we've wasted memory. We have, and sometimes a lot of memory. We've reserved all this memory that we can't use, and that may have repercussions. But if we guess too small, we're going to run out of room and have to start over again in essence, or have to rewrite the program. Okay, so we're assuming we have no more than 50 students. Okay, so I've got this number of students I'm going to track. This is number of students that have been processed, basically. Okay, and then this is kind of the one line way to open a file, which I don't know if we covered, but this is the quicker way to do it. We're going to have our IF stream. It's going to call it in file. We're giving it the name that opens it, and we're good. Okay. And then remember, with the file stream, it works like the input output streams. So it works as like a CN. So in file then is going to function as the CN. It's going to give us the student ID, that's the array, at position 0, what we just said. Okay. If we do it again, it's going to get us the next thing on that line. Okay. So the next thing on that line is going to be, it's going to go to the course grade at that same number of students. So course grade sub 0 at first. Okay. Then we're going to say while in file, which means while there's still data there, and while the number of students is less than 50. We can't deal with more than 50. Ideally, we would have an error message if it goes above 50. But anyway, this is what we're doing for this one. We're start by incrementing the number of students. Okay. We're then just going to read again into the data, into the array, read the student ID and course grade. We're going to keep doing that to populate the array. Okay. If you're dealing with parallel arrays, one of the challenges, every time you add something to one of the arrays, you have to add it to the other array. Every time you delete something from one array, you have to delete it from the other array. So you just have to, there's some manual manipulations there that you have to be concerned with. Okay. So it's important that you keep track of that if that's the way that you decide you're going to go with your program. Okay. So the next thing I wanted to talk about is the idea of two-dimensional or more than one-dimensional arrays. Okay. So we often see data in this format. This is the idea of a row and a column. Okay. So if we were doing a multiplication table, for example, it would have rows and columns, it's not a linear data structure. We're now talking about a two-dimensional data structure. Okay. So when we're going to declare these two-dimensional arrays, okay, we do it in the following manner. So we're going to start with the data type, whatever the data type is going to be. It's going to be whatever the array name is, and it's going to be two different. So we could do rows here. That's going to be an integer for that, and columns. We could think of it that way. Okay. So two numbers. Okay. Uh, and what we're really doing when we think about it is that we know that in C++, an array has to hold a homogeneous data type. Okay, so the normal arrays we've done so far have done, let's say, an array of ints or an array of doubles or whatever. Okay, we're now saying that we're going to have an array where each element in the array is also an array. Okay, so that's kind of the idea. So the first element of our array holds another array. Okay. And the second one holds a different array, things like that. That's kind of where we're headed on that. Okay. So if we have such an array, so let's say that we have, we're going to do a sales array. Okay. And the sales, so it's going to be of type double. And let's just say for this instance, we'll have 20 rows. I don't know, 20 columns. Doesn't matter. Okay. The very first element in that array will be at sales 0, 0. Okay. So sales, so let's break this down. Sales sub 0 is going to be what we're holding there is going to be an array of doubles. That's the first array of doubles. Okay. But if I say 0, 0, that's going to be the first element of the first array in sales. Okay. So that's kind of what we're doing with that. Okay. And we can just say something like this. We can give it a value. Okay. That's perfectly legit, like we could with anything else. Okay. So that's kind of the basic idea. Okay. So no matter what we're trying to deal with here. So if I were to say instead, let's say a 5 and a 3. Okay. This says that we're going to go to the fifth array that we have. Okay, so row 5, column 3, the third element of that fifth array. Okay, so that's kind of how that's going to go. Okay, so if we want to do an array where we specify as we initialize it as we specify, in one line, we could do the following. And there's a trick here for how we're going to format this. I think that'll make it easier. So let's say we have an integer called board. This is an array. It's going to be a 4 by 3. So we have 4 rows and 3 columns. Have it equal. Okay. We're going to put 2 curly braces here. Okay. And then the first row is 2, 3, 1. Okay, comma. We're now going to hit an enter. Do another curly brace, and it's going to line things up for us. Okay, and if we do 15, 25, 13, again, a comma, another curly brace, do a 20, do a 4, do a 7, comma, curly brace again. And now the fourth row is 11, 18, and 14. Okay. So this ends that array. Another one ends the whole array. And notice that in Emacs it lights up appropriately. Okay. So that's the idea. So again, if I were going to see out, and this wouldn't work actually because we can't print out an array, but what's at board 0? Okay, so board sub 0, what's there is equal to the array 2, 3, 1. Okay, so that's what is at board 0. Okay, where board 0, 0 would be equal to 2. Okay, and I think by putting that return there and breaking it up, you get the idea of what our matrix is going to look like in essence. Okay, so that's an important thing to do there. Okay, so once we have one of these, how are we going to process this? Okay, what we typically are going to do, and let's also be clear here, this is even more important, I think, that we want to set up now two constants. So we have a constant and for rows equal to 4. We have a constant and for calls equal to 3. Okay, and then I would replace this with rows and calls. Okay, and those are constants for us. Okay, so if we want to go through all of the elements in the list, okay, so we're going to go through all of that. Okay, then we're going to write a couple of for loops. Okay, so we have to loop on the outer loop. Typically, we're going to loop by row first. We want to do row 1, then row 2, then row 3, then whatever. Okay, and then within that loop, we're going to do a different loop where we're going to go column by column. Okay, so in this case, if I do for right key, int r, let's say for row equals 0, I want r to be less than rows, and I want an r plus plus. Okay, and that. So this is going row by row. Okay, so r will take the value of 0, in our case, 0, 1, 2, and 3. Okay, in fact, we can see out r here, okay, to show that. Now, inside of this loop, okay, so the first time we're through here, we're on row 0. So now let's do another for loop, okay, for int c equals 0, and I should have spaced that out more. You know, it's a little thing, but being OCD a little bit is probably a good thing as a programmer. C is less than calls. C++. Okay. And this is going to get each column. Okay. So now if I'm going to see out, and I'm going to make this a tab character first, so we can kind of see what's happening. The C. Okay. With these embedded loops, what we're going to get a 0, and then it's going to tab over for 0. And we're going to go ahead and get all the columns before we go to a different row. Okay, so we're going to get 0, 0, and tabbed over for a 1 and for a 2. Then we're going to get row 1 and so forth. Okay. So let's take a look at this and see if I've made some ridiculous typo, which I have the ability to do for sure. Just can't type at all. Good Lord. /a .out. There we go. And you see exactly what I'm talking about here. Okay. We start with row 0 and we do column 0 and then 1 and then 2 and then row 1, 0, 1, 2, row 2, 0, 1, 2, row 3, 0, 1, 2. Okay. So as far as the processing goes, so let's take a look at this. Instead of printing this one out here, this is going to be the pairs we're going to deal with. Okay, so I'm going to see out the R and then the tab and then that. Okay, so this is the order we're going to access our array. Okay. And there are other ways to do this, but this is the most natural way that we're going to do it. Okay, so we're going to go from 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, all the way down to 3, 0, 3, 1, and 3, 2. Okay. So what this means as far as the array goes, we're going to start with 2, and then 3, and then 1, and then 14, and then 25, and then 13, and so on. Okay. So this is the way we're normally going to do this. This is a row first way to go. Okay. You can flip those around and go column first if you want. You can do whatever you want, but this is the most natural way to do it. Okay. And if we wanted to print out instead of the row and column, let's just put out what's in those positions just to make sure this is making sense. So I'm going to print out here the board RC. Okay. And that should print things out in the order we expect. And there we go. We go from the 2 all the way down to the 14. But that doesn't really give the feel for what it looks like. Okay, so what we're going to do instead, and this is pretty common as well. Instead of doing a new line when we print things here, I'm going to go ahead and print a tab character. And if it's too big, you may just have to put a space, but let's try a tab. I think our numbers are small enough. Okay. And then, so what this is going to do, this is going to go, if we're coming down through the code, R gets 0, C gets 0, we're going to print out the 0, 0 or the 2, then we're going to print out the 3, and then we're going to print out the 1. Okay. Ideally, and now we're going to loop. Now this for loop is done with its first iteration, and then we're going to go back to the outer for loop to get the next row. Let's go ahead and print a new line character or an end line character here. Okay. So let me go ahead and do a CC in or C out indel. Okay. And that should give us the rows that we want. Okay. Take a look. Process that. And you see now this looks more like what we want. We've done row 1. Okay. With our inner loop. When we're done with the inner loop, print a new line, go to row 2, inner loop, and so forth. Okay. So this is the way that we deal with this data. Okay. Print would look this way. We would do the same thing if we wanted to do any kind of manipulations. The book has some examples for an input loop. If you know you're going to have, a 3x3 two-dimensional array, then you can go through and have them input the data in that order with CNs. You can do row sums, column sums. You can do the largest element each row, largest element of each column. All those are things that the book has some examples of, and we'll see some of this in the homework problems. Okay, so since a two-dimensional array is just an array of arrays, the rules for when we pass it to a function are exactly the same. Okay, so there's no difference there. It's going to, by default, pass by reference. But remember, so let's take a look at that code while we're here, might as well. So let's say instead of printing it this way, let's say I want to make this a function. Okay, so I'm just going to have a function down here. I'm going to call my function void print array. Okay. And it's going to take, and here's the key point. We're gonna need a constant here. Okay. Call it array. Uh, two brackets there. And then, okay, so it's an int. Okay. Int S for size. Should be all we need for that. Okay. I can then, can I still yank that? Yeah, it's still there. Okay. The only difference is instead of board, this is more generic. This is going to be calls it an array, but I don't know that I can, that may be a reserved word. So let's just call it AR. Okay. For this one, we probably, so in this case, we have the number of rows, the number of columns as a, did I make it global? Maybe I didn't. No, that's not global. So you typically would want to pass for a 2-dimension that as well. Okay. So we would have to have here, and let's, do we need the length? We don't need the length, actually, do we? We need the rows and columns. That'll give us the length that we want. So we're going to have an int for R and an int for C. Nope, that's wrong. Int for rows calls. Those are lowercase, which they're not the global variables. Because they're not global variables anymore. They're not global. They're constants outside of this, but not here. Okay, so that should do that. So again, we pass in. We don't need to have any ampersands here at all. So instead of the length, we're going to break the length into the rows and the columns. Okay. Then if I cut this or kill it and paste it up here, see what kind of crazy errors I've made. Um, should be okay. Let's see. Don't know what I'm forgetting, but probably something. Yep, something. Okay. Oh, okay. So I have to send along to that the size. Okay, so let's see, does it show an example of that? To make sure I get the syntax right. Okay, we're sending along. Oh, the number of that, and that's really strange that the first one has to be there. There may be a reason for that. I have to think about that. That they're putting um, in this first number here, they're doing the call. So they do make it a global, but the rows can be separate. Okay. But that would mean I would have to take these guys. Okay. Let's see if this fixes this down here. Doing something. But it was declared in that scope. So I just made it. Oh, it wasn't declared. It's got to be before that. Still doesn't like something. That's what I did. Declaration of AR is multidimensional array must have bounds for all dimensions except the first. Okay. So, oh, got calls in the wrong space. That's the problem. And I guess the reasoning behind this is that we can tell from when the array comes in, we see the outer values. so we can get the rows, which we've done before, but we don't know what's underneath that in the memory. So that's the issue. So hopefully that will fix it. Different issue. Okay. Oh, I didn't change that correctly. I don't have that anymore. That should be calls with capitals. Okay. So again, if you have more than one dimension, you have to send along the actual value for anything but the first. It can tell the first. It knows what the first is, but it can't get anything beyond that. Okay. So that's the basic idea with the two-dimensional. Um, beginning programmers tend to have trouble sometimes figuring out the order in which things go. So just remember this example that we start with the rows, and then we go through and do the columns inside of each row. And that's how those nested loops work. And I think it won't be too bad. Okay. Um, I think we've probably been there for a while, but we're really there now. It's where sketching out your answer or your solution on paper uh, will help you visualize what's happening. We're getting more and more things we have to keep in our heads if we choose not to write stuff down. So I think it's a good time to start doing that. Okay. So if you have questions, as always, make sure you let me know. This is a little bit complicated, but I think we'll make it.